Good morning to all of you. I'm Simran, a PhD student from Chemistry Department of IIT Bombay. So today I'm going to take a problem session of the topic Introduction to Organic Chemistry Second, which is running on the NPTEL platform of IIT. So I'm your TA, and I'm conducting a problem session every Sunday at 3 to 4. So this would be my first problem session. So I will be sharing my screen and will let you know for the further sessions. I hope you guys can see my screen. So I have prepared some slides regarding the problems. So this is particularly on the organic chemistry and concept based problems. So we will be starting with the very easy and readily answerable questions. So first of all, the problem one, I will start with the problem one, and the problem one contains the problem one contains that first we have to identify the polar protic solvent of the following. So here we can answer this very easily if we know the basic, right? So the basic is what are the polar protic solvents? So first, I would like to remind you that the polar protic solvents are nothing but the solvents which have at least one hydrogen that is directly attached to an electronegative atom. So we have previously studied that the electronegative atoms are like fluorine, oxygen, nitrogen, which are present on the periodic table. Okay, so, the requirement for the polar protic solvent will be like it should have one hydrogen that is acidic, right? How it comes to acidic? So, when it is connected to the electronegative atom, that electronegative atom will pull the electron towards it and makes the proton acidic. So, that is known as a polar protic solvent. So, now we will figure it out from the four, that is acetone, toluene, acetic acid, and acetonitrile, which is the polar protic solvent. So starting from the acetone and toluene. So as you can see here, this hydrogen of acetone is connected to the carbon, which is not electronegative in nature. So here the hydrogens here is not acidic. So we can say that it is not a polar protic solvent, as on dissociation it will not give you a proton. So acetone is not the answer. Now coming to the toluene. Toluene molecule also, the hydrogen are attached to the carbon, which is not electronegative. So it is not making it acidic in nature. Here also, the hydrogen which is connected to this benzene ring is also not acidic because it is in turn connected to the carbons. So we can say that it is not a polar protic solvent. Now, coming to acetic acid and acetonitrile, in the case of acetonitrile, guys, these hydrogens are connected to carbon. If these hydrogens are directly connected to this electronegative nitrogen, then we can say that yes, there is acidity. But here, these hydrogens are not acidic. So these are not acidic because it is not connected to any electronegative atom. Now coming to acetic acid, here basically, these hydrogens are not acidic, but look at this OH. This proton is connected to an electronegative atom, that is oxygen. So it is providing acidity to this particular hydrogen. So now it is termed as a polar protic solvent because on dissociation it will give you a proton, right? So the answer will not be toluene, not is the acetonitrile. The answer would be acetic acid. I hope you guys got the problem. Now, coming to the problem 2, here the molecular formula of DDT has how many chlorine atoms? So it is a very straightforward question. If you look at it, you just have to know the molecular formula or the chemical structure of DDT and then you have the answer. So this is the formula. This is the chemical structure of DDT. So we can count that how many chlorines are there, right? So in this, one, two, three, four, and five. These five chlorines are there. So we can directly go to option A and say that yes, five chlorine atoms are there in the DDT molecule. Now coming to the problem 3. In this case, you have to identify the correct sequence according to the electronegativity. So, as we all have learned, what is electronegativity? So, electronegativity is nothing but the capability of a atom in a molecule to attract the shared pair of electron towards itself. So it is attracting the electrons towards itself. So the tendency that how this atom is attracting that lone pair or the shared pair of electron towards itself is the electronegativity. So we have seen that the period in the periodic table when we goes to through a period along a period from boron to carbon to oxygen to nitrogen to oxygen and to fluorine, the electronegativity increases. So, applying that concept here, only that concept will get you the answer, right? So, in the look at the first option here, fluorine is electronegative than nitrogen, then electronegative than carbon, which is turn is more electronegative than oxygen. So here you can find the loophole that carbon is not electronegative than oxygen. So it is definitely not the correct option. Here, nitrogen is electronegative than fluorine, which in turn is electronegative to carbon, and which in turn is electronegative than oxygen. This is also not the trend because fluorine is the most electronegative atom here. So this is also not the answer. Now coming to the option C, it is fitting the fluorine as a least electronegative atom, which is not correct. So this option is also not correct. Now, coming to the option D, here they have given that fluorine is more electronegative than oxygen, which in turn is more electronegative than nitrogen, and which in turn is more electronegative than carbon. So, this is the correct option. Now, coming to the problem 4, I hope you guys are catching up with me and these problems and the solutions are very much clear to you. So, coming to the problem 4, here they are saying that arenes does not undergo what? So these are the four options amongst which we have to identify that arenes does not undergo what. So first we have to know what are arenes. So arenes are the uh, are the molecules or the compounds having a benzene ring, right? So a simplest arene we can think of is benzene itself. So arenes contain a benzene moiety into them. So arenes are showed. There are various papers where they have shown that arenes undergo these kind of reaction, that is the coupling, halogenation, cycloadditions. But think of dehydrogenation, sorry. So dehydrogenation, first we have to know what is the dehydrogenation. So dehydrogenation is the chemical reaction that involves the removal of hydrogen, usually from an organic molecule. So removal of hydrogen. Arenes are itself sp2 hybridized system, right? So if we are going through a dehydrogenation process, then it leads to the formation of an sp hybridized carbon. So going sp2 hybridized, as we know that it is a planar system, right? So as we are going from sp2 to sp hybridized system, then the planarity will get disturbed, right? So arenes does not undergo dehydrogenation reactions. So it can give you a clear cut idea that why it is not giving the dehydrogenation reaction. So I hope this problem is clear to you. Now coming to the problem 5. Now here we have to discuss the stability sequence of carbocations. So as we know that the carbocations are nothing but electron deficient sp2 hybridized systems. So carbocations are sp2 hybridized. So here we have to comment on the stability of them. So stability. So as we know that carbocations are electron deficient species, right? So first we have to know how like primary, secondary, and tertiary carbocations looks like. So here I have shown the primary, secondary, and tertiary carbocation structures. So here in the primary carbocation, it is connected to only a one carbon atom. That is this. Now in the secondary, it is connected to the other two carbon atoms. In the tertiary carbocation, it is connected to the three carbon atoms. Now, the carbon increasing the number of carbon atom, what is it indicating? Here, the primary principle is that the carbocations, as it is electron deficient, right? So they are uh, here the carbon are imparting the inductive effect on the carbocation so that the electron density at this carbon is increasing, right? So as we know that the alkyl groups have plus I effect, that is plus I inductive effect. So due to inductive effect, it is increasing the electron density at this electron deficient carbocation. Right. So more number of alkyl group adjacent to this carbocation will increase the electron density. Right. So making it more stabilized because it is electron deficient. So it wants that much more electron density would be surrounded like along it. So increasing the electron density at its surrounding will be increasing the stability of that carbocation. So first reason is that the inductive effect is playing here the role. Second reason could be hyperconjugation. So in the hyperconjugation, we can think about like for the tertiary carbocation, hyperconjugated structures are much more than the secondary, which in turn is very greater than the primary carbocation. So it is also providing the stability to these system. So we can say that the stability of the tertiary carbocation is much greater than the secondary carbocation, which in turn is also greater than the primary carbocation. So I hope it is clear. Now we can look at the problem 5. So here they have given the sequence just opposite to the right order. Here they have given that primary is more stable than secondary, which in turn is more stable than tertiary carbocation, which is very much wrong, right? So we have studied that the tertiary carbocation is stable than secondary, which in turn is more stable than primary carbocation. So this sequence is incorrect. So is this sequence correct? No. Right. I hope the solution is very much clear to you all. Now, coming to the problem 5. So, here we have to identify the one which, on reaction with the carboxylic acid, is going to give an ester. So, ester formation is there. Okay. So, we have to look out which guy, like out of these four, which guy is able to give the ester formation with the carboxylic acid, right? So, here the options are like ketone, alcohol, aldehyde, and sugars. So, first of all, the formation of an ester in the reaction is known as the esterification reaction, right? So, we have to first know what is the esterification reaction. So, an esterification reaction is a process of combining an organic acid with an alcohol to form an ester. The byproduct here is the water, right? So, for a chemical reaction, water is the byproduct, and here the two coupling partners, that is the acid and the alcohol, is playing role to give rise to an ester. So, by this information, we can say that yes, the second coupling partner with an acid is alcohol, which is readily giving the ester. Okay, so out of these four, the guy which is giving an ester is alcohol, right? Now, coming to the problem 7, here we have to discuss which of the following has a zero dipole moment. Okay, the first option is benzene, ammonia, hydrogen sulfide, and nitrogen oxide. So, now we have to first know the concept here, which is dipole moment. So, what is dipole moment? We have to trigger it that what is the dipole moment and how we can use in this particular question to answer that which one has a zero dipole moment. So, first of all, we need to know what is dipole moments. So, it is the difference, it is actually arise due to the difference in the electronegativity between the two atoms that is chemically bonded to each other, right? So I have taken an example here, that is the HCl. So in the case of HCl, here one atom is hydrogen and one is chlorine, right? So chlorine, we know that is very electronegative than hydrogen. So dipole moment is itself a vector quantity. What is meant by a vector quantity? It has a magnitude and has a direction, right? So the dipole moment is directed towards the chlorine atom as it is much more electronegative than hydrogen. So dipole moment will be facing towards this, right? So we can say it has a dipole moment because it doesn't have a same magnitude, equal magnitude, opposite direction vector, which is cancelling it, right? If we have in a system, if we have this now, then the dipole moment is zero. Okay, so mark my words that if in a system we have a dipole moment which is equal in magnitude and in opposite direction, then the dipole moment of that particular molecule is zero. Okay, and also in the case of symmetrical molecules, the dipole moments are zero. Now coming to the ammonia. So this is the structure of ammonia. So here nitrogen is electronegative than hydrogen. So the vector will be pointing towards nitrogen. Here also it is towards nitrogen. Here also it is towards nitrogen. So the resultant vector will be like what? This. So it has a non-zero dipole moment. Okay? It's like कि we doesn't have any other vector to cancel it. We doesn't have another vector which have a equal magnitude and is applied at the opposite direction to cancel these particular dipole moments. If we have that system, then the dipole moment will be zero for that particular molecule. Now coming to the H2S, here also sulfur is more electronegative, so the dipole moment is oriented towards sulfur. Here also, so the resultant dipole moment will be upward. So here also it is a non-zero dipole moment. Now coming to the nitrogen oxide, here the oxygen is much more electronegative than nitrogen. So it is oriented towards the oxygen, the dipole moment. So it is also non-zero. But in the case of benzene, here all the atoms are carbons. So the electronegativity difference is not there, right? And dipole moment is itself rising due to the difference in electronegativity between the bonded atoms. So here the bonded atoms are same. The electronegativity difference is not there. So the dipole moment of this molecule will be zero. Okay. So uh, the correct option will be benzene ring. Not the ammonia, not the hydrogen sulfide, and not NO. It is benzene which has a zero dipole moment. So I hope it is clear. Now I'm going to the problem 8, in which we are asking that primary alcohols undergo what reaction to form alkenes. So primary alcohols, they are undergoing a reaction to form alkenes, right? So which is the reaction which leads to the formation of alkene from alcohol? We have to figure it out. So the options are elimination, oxidation, reduction, and hydrolysis. So whether it is elimination, whether it is oxidation, whether it is reduction or hydrolysis which is giving the alkene, so one has to think about it. So we have to first know that the structure of primary alcohol, right? So these are the structure of primary, secondary, and tertiary alcohol. So here, uh, this bonds are connected to hydrogens, right? These are hydrogens. All of three are hydrogens. Okay, so these are hydrogens. Now we have to figure it out that how an alkene formation will be going to takes place here. So whether we go for the oxidation or reduction or hydrolysis. So when we are going to take a oxidation reaction here, we will end up with a ketone, right? So no alkene formation will be going to take place. With the reduction also, it is not going to give you alkene. With hydrolysis also, it is not going to give you alkene. So it is the elimination process by which we can we can form a double bond here. or double bond here. It is the elimination process which will lead to formation of alkenes. So the primary alcohol undergoing formation of alkene by elimination. So this is the correct option here. I hope you guys got it. Now I'm going to the problem 9. So problem 9. Here they are asking that which species are formed due to homolytic bond cleavage. Right? So first we have to know what is the homolytic bond cleavage. So a homolytic bond cleavage is nothing but a breaking of a covalent bond, right? A breaking of a covalent bond in such a way that two atoms will get one electron as a shared pair, right? So as we know that a bond is formed with the two electrons. One atom is giving one electron, like one electron from both the atoms and adding up to give a single bond, right? So two electrons are there to form a chemical bond, covalent bond, right? So if we are breaking that chemical or covalent bond in such a way that the each of the atom will get one shared electron, so that is known as homolytic bond cleavage. So here, as I have seen in the case of bromine, one bromine atom is getting a one electron, and other bromine atom is also getting an electron. So this leads to formation of what we known as free radicals. So free radicals are single electron species, right? So here, so which species are forming in this particular breakage? It is the free radicals. Now there is something called heterolytic cleavage. One should have to know that also. It is a type of cleavage in which that covalent bond is breaking in such a way that both the shared pair of electron is donated towards the one atom. Like if it is a same case with this molecule, then this covalent bond is breaking in such a way that all of the two electrons that is here to form this particular bond is transferred to this Br to form a Br minus, that is a anion. And here a carbocation is getting formed, right? A carbocation is getting formed. So the species which is forming in the heterolytic bond breakage is anions and cations, right? So ionic species are forming in the case of heterolytic bond cleavage, but in the homolytic bond breakage, free radical formations are there. So I hope it is clear. Now coming to the last problem of this session. So this will be the last problem, and guys, please pay attention towards it as it is a very important reaction and also a very effective transformation for doing an transformation from ketone to alkene. Here, as you have seen that many reagents are there to convert this ketone to alkene. So they are asking that whether this transformation will takes place with the diazomethane or with the methyl lithium with Gilman reagent or a Vedic reagent, right? So look at this very closely. So here, this ketone has one, two, three, four carbon atoms, right? Which is the reactant, and the species on the right hand side is the product, which is having five carbon atoms. Okay, so we also have to figure it out that we are adding in carbon in the system, right? So if we have to carry out this transformation with let's say with the reagent A, with the diazomethane. So diazomethane is a basically a reagent which will convert the acidic proton into methyl, right? It will convert, or it will just take up the acidic proton and generate some methyl there. So if we have to convert acid into ester, then it could be a good option. But in this case, you don't need this, right? So it would be not a reagent that will lead to give you an alkene with a ketone. So going to the methyl lithium will generate a alcohol here, and it would not add an extra carbon for sure, right? So it is not the reagent which is of use here. Also, the third reagent, that is the Gilman reagent. that is the Gilman reagent, is similar to the methyl lithium, that it will also giving you the alcohol formation instead of the alkene. So it is not the required reagent here. So coming to the reagent D, that is a Wittig reagent, right? So Wittig reagent will give you the formation of alkene with an extra carbon atom added, right? So the particular mechanism for this transformation is like, first of all, uh, this anion will attack on the ketone carbonyl, and then the formation of this four member species would be taking place. That four member species is known as the oxidane. This is the oxidane ring which will get formed, and then the cleavage of this oxidane ring will give you the phosphine oxide formation and with an alkene, that is the product. So this is the required mechanism of this reaction, and so we can generate a ketone, sorry, a alkene from a ketone with an extra carbon atom by Wittig reaction. So please keep this in the mind, and these are some concept-based questions which one finds very easy to answer. So I am starting this session or starting this station with this particular problem, so that everyone will indulge in this particular course, which is Introduction to Organic Chemistry. So I will be taking this problem session every week on Sunday at 3 to 4, as I have mentioned. So please be there, and thank you so much for your patience listening. And I hope to meet you guys soon. And now I'm just stopping this particular session, and thank you so much.